The capacitor is the essential component of any circuit design, and in fact after the resistor it is the second most used passive component in the circuits. Now these capacitors are available in various sizes and shapes, but the basic function of any capacitor is to store the electrical energy. So now in this video let us understand how does this capacitor works and how the energy is stored across this capacitor. Now this capacitor consists of two conducting plates which are separated by a dielectric material. Now this dielectric material is the insulating material and it opposes the flow of current. So now let us understand when we apply the voltage to this capacitor, then how the energy is stored across this capacitor. Now before the application of voltage, the two conducting plates of this capacitor are electrically neutral. It means that it has an equal amount of positive as well as the negative charge. But once the voltage is applied to this capacitor, then from the top plate, the electrons or the negative charge is attracted towards the positive terminal of this battery. And through the negative terminal of the battery, the electrons are pushed towards the bottom plate of this capacitor. Now because of the dielectric material between the two plates, the electrons which are collected at the bottom plate of this capacitor are not able to cross this barrier. And because of that, you will observe that over the period of time, the electrons will get accumulated at the bottom plate of this capacitor. So over the period of time, the top plate will have a shortage of electrons while the bottom plate will have a excessive electrons. Or we can say that the top plate will get positively charged while the bottom plate will get negatively charged. And because of the charged particles, the potential difference will get developed across the two plates. Now the building of charges across the two plates will continue till the point the potential difference that is developed across the two plates is equal to the supplied voltage. Now because of this potential difference, the electric field will get developed across the two plates, and this developed electric field is directly proportional to the potential difference and it is inversely proportional to the distance between the two plates. So smaller the distance between the two plates, the stronger will be the electric field. So in this way, when we apply the voltage to the capacitor, then the charges are developed across the two plates of this capacitor, and because of the development of the charge, the electric field is developed between the two plates. So in this way, the capacitor stores the energy in form of this electric field. Now even if we remove this voltage source, then also the charges that is developed across the two plates will remain as it is. So unless we apply the conductive part to this capacitor, the charges that is developed across the two plates will remain as it is. So as you can see over here, the conductive path is connected between the two terminals of this capacitor, and the load in the form of bulb is connected to this conductive path. So now whenever we turn on this switch, at that time the electrons from the bottom plate will get attracted towards the top plate, and in this way you will see the transfer of charge or flow of current through this conductive path. So now because of flow of current, you will see that the bulb will glow, and in this way the current will flow through this conductive path, and this procedure will continue till both the plates will become electrically neutral. So over the period of time, you will observe that both plates will become electrically neutral and there will not be any flow of electrons through this conductive path, and because of that the bulb will again turned off. So in this way, the charge that was developed across the capacitor has been discharged through this conductive path, and this phenomenon can be known as the discharging of this capacitor. Now the ability of the capacitor to store the charge is known as the capacitance, and it is represented as the charge that is developed across the capacitor per unit voltage, and generally it is denoted by the unit of Faraday. Now this Faraday is very big unit and usually it is not used to define the capacitance. Rather very small units like millifarad, microfarad and picofarads are used to define the capacitance. So now for the given capacitance, if you want to store the more charge across the capacitor, then you need to apply the more voltage across that capacitor. Or for the given voltage, suppose if you want to store the more charge across the capacitor, then you need to select the capacitor in such a way that it has a large capacitance. So as you can see over here, by changing the applied voltage, we can change the amount of charge that is stored across the capacitor. But here we cannot increase the voltage indefinitely. So for every capacitor, you will find that the maximum voltage rating has been defined. So the voltage that is applied across the capacitor should be less than that maximum rating. So if the applied voltage is greater than the maximum rated voltage, in that case you will see the dielectric breakdown in the capacitor. So now let us see the factors which affects the capacitance of this capacitor. So there are three factors which affects the capacitance of this capacitor. The first is the area of the plates. Then the second factor is the distance between the two plates of this capacitor. And the third factor is the permittivity of the dielectric material. And the relation between three can be given by this expression, that is C is equal to epsilon A by D. So as you can see over here, the capacitance of this capacitor is directly proportional to the area of the plates as well as the permittivity of this dielectric material, and it is inversely proportional to the distance between the plates. So now let us see how these factors can affect the capacitance of this capacitor. So the first factor is the area of these plates. So as the area of this plate increases, the amount of charge that can be stored across the plates will also increase, and in a way we can say that the capacitance of the capacitor will increase. Now the second factor which affects the capacitance is the distance between the two plates. So now as the distance between the two plates reduces, the electric field that is developed across the two plates will also increase, because it is inversely proportional to the electric field. And as this electric field increases, the charge that can be stored across the capacitor will also increase. So the third factor which affects the capacitance is the permittivity of the dielectric material. Now this permittivity can be defined as the product of absolute permittivity and the relative permittivity, where this relative permittivity is also known as the dielectric constant of the material. So because of this dielectric material, the capacitance of the capacitor will increase. So now let us understand how this dielectric material affects the capacitance of the capacitor. Now like I said before, this dielectric material is the insulating material, so it will not allow the flow of current. But this dielectric material has a polar molecules. It means that whenever there is a no electric field, in that case these molecules are aligned randomly. But whenever the external electric field is applied, in that case these molecules align themselves according to the electric field. So at the top edge of the dielectric material, if you see, you will find the negative charges, while at the bottom end of this dielectric material you will find the positive charges. Now these charges develops its own electric field which opposes the electric field that is generated by the capacitor. So because of this dielectric material, the effective electric field of the capacitor will reduce. And in a way we can say that the potential difference that is generated across the two plates will also reduce, provided the charges that is developed across the two plates are constant. So in that case, to increase the potential, we require the more amount of charge across the two plates. So in a way we can say that because of the introduction of this dielectric material, the capacitor can store more amount of charge, or we can say that the capacitance of the capacitor will increase. So these are the three factors which affects the capacitance of this capacitor. So I hope in this video you understood how does the capacitor works and which are the factors which affects the capacitance of the capacitor. So if you have any question or suggestion, do let me know in the comment section below. If you like this video, hit the like button and subscribe to the channel for more such videos.